Okay, in this section 7-5, our topic is geometric mean. Now let's talk about regular mean for a minute. Mean is just the average. So to get the average between two numbers, you add them together and divide by 2. However, geometric mean of two numbers is a little bit different. So to get the geometric mean of two numbers, you multiply them together and then take the square root of the product. So like I say, for regular mean, add them together, divide by 2. For geometric mean, multiply them together and take the square root. So that's how geometric mean is different from regular mean. Now, by taking this equation and dividing by both sides by squaring it and then dividing both sides by ax, then you can come up with this equation right here, okay, which is a proportion. So you can rearrange this and turn it into a proportion and turn it into this proportion, all right? Okay, now, there are two theorems that we're going to be looking at. And the first one says the altitude is the geometric mean between the two segments of the hypotenuse. So the altitude is the geometric mean between the two segments of the hypotenuse. So we're going to take this proportion, all right, and we are going to relabel this as A is going to be relabeled as the first number in the geometric mean. B is going to be relabeled as the second number in the geometric mean, and then the x is going to be relabeled as the geometric mean itself of those two numbers A and B. All right, so again, when we take a look at this, okay, then what does the theorem say? The altitude is the geometric mean. So the altitude, remember, is from a vertex and hits the opposite side 90 degrees. The altitude is the geometric mean. It's going to be labeled as geometric mean between the two segments of the hypotenuse. So the altitude cuts the hypotenuse into two pieces. Here's the first piece, here's the second piece. The geometric mean of these two numbers is the length of the altitude, right? So my first number is this piece. My second number is the other piece of the hypotenuse, and then the geometric mean goes here and here. So again, that's taking this proportion and turning it into this, all right? So again, the geometric mean, the first number goes here, the second piece of the hypotenuse goes here, and then the altitude goes here and here, all right? And one of these things would be missing, and then we would solve it. Use this equation to solve it, all right? Okay, so there's a second theorem. It says each leg is the geometric mean between the hypotenuse and the segment of the hypotenuse adjacent to that leg. So let's see what that theorem says. Okay, each leg is the geometric mean. So the leg, remember you got legs and a hypotenuse, the leg is the geometric mean between the hypotenuse. Now that means the entire hypotenuse, the whole thing. So the first number is the entire hypotenuse, and the second of the segment of the hypotenuse adjacent to that leg. So out of the two pieces, your second number is the piece that's adjacent to or connected to that leg. All right? So this leg is the geometric mean of the whole hypotenuse and the piece that's connected to that leg. Okay, so these are really the two setups that we're going to be using. All right? So either the altitude is the geometric mean between the two pieces, or the leg is the geometric mean between the whole hypotenuse and the piece of the hypotenuse connected to that leg. It'll be one of those two setups. Okay, so now, how we utilize these theorems becomes a little more apparent once we actually start taking a look at some of the problems. All right, so like on this first one, our task is to find x, y, and z. Now, when we come to a problem like this, let's start off with trying to find x. So the first thing that you need to decide is which theorem are you going to use to set this up. Okay, and how do you decide? Well, it depends on whether the altitude is involved with what you're trying to find, in which case you would use the first theorem, or if the leg is involved with what you're trying to find, in which case you would use the second theorem. All right, so if we're trying to find x, look at the position of x. Is x an altitude, or is it one of the legs? All right, well, my x is an altitude. So that gives us the clue that we're going to be using the first theorem. So we're going to set this thing up with the first theorem. Okay, so now, in order to set it up, go ahead and write in your blank proportion, and then we'll plug in the parts one at a time. Now, remember, the geometric mean goes here and here, right? the altitude is the geometric mean. So whatever the altitude is would go in these two spots. Okay, so my altitude in this case is x, which means I'm going to put an x in this blank, and I'm going to put an x in this blank. So these are the two blanks that are going to have x's in them. Now, what's the rest of the proportion? Okay, the geometric mean, or excuse me, the altitude is the geometric mean between the two pieces of the hypotenuse. So this piece of the hypotenuse will go for the first blank, and this piece of the hypotenuse will go in the second blank. Okay, so what's the first piece of the hypotenuse here? It's 2, so 2 will go in this blank. What's the other piece of the hypotenuse? 5, so 5 will go in this blank. And then there is the proportion or equation that we're going to use in order to solve for x. So once you've got this set up, it's just a matter now of solving for x. And again, just as long as you put the three pieces in the right place, you're good. Geometric mean or the altitude, whatever the altitude is, goes here and here. Whatever this first piece of the hypotenuse is goes here. The second piece goes here. And now let's solve it. How do we do it? With cross products. X times x is x squared. 5 times 2 is 10. And if I wanted to find the value of x, I would now need to take the square root of both sides. Square root of x squared is x. And then the square root of 10 is going to leave me with 3.16 as the correct value for x. That's your value for x. Okay, we're not done yet. We've got to find y and z. So now, let's take a look at y. Okay, so y is one of the legs. So if y is one of the legs, then which theorem am I going to use? The first one, which involves the median, or the second one, which involves the leg? Of course, the answer would be the second one, because y is a leg. So I'm going to use the second setup for this particular one to solve for y. So once again, just like we did last time, start by drawing in your blank proportion, and then we will fill in the fractions correctly. All right, so now on this one, remember, fill in geometric mean. Geometric mean goes here and here. In this case, with this theorem, the geometric mean is the leg. So what's the value of the leg in this case? It's y. So that means y goes in for GM here and here. Because remember, whatever the leg is, that's what you plug in for GM. Right? And so the leg is y, so y goes here and here. Now, what's the rest of the theorem? The first number is the entire hypotenuse. So this first blank that I need to put in should be the entire hypotenuse. Now, is the entire hypotenuse 2 or 5? Okay, the answer is neither one. The entire hypotenuse is 2 plus 5, which makes 7. So remember, in this theorem, the theorem with the leg, okay, the first number, or the first blank in your fraction there, in your proportion, has got to be the entire hypotenuse. And more often than not, you will have to add these two pieces together to get the entire hypotenuse of 7. All right? So again, the first number is the entire hypotenuse with this leg geometric mean theorem. Now, what's the other blank going to be? The second number is going to be the piece that's connected to the geometric mean. All right? So out of 2 and 5, which one's connected to the y? Which one's connected to this leg? The answer, of course, would be 2. So my 2 goes here. Now I've finished my proportion. Once you've finished your proportion, you're ready to solve it for y. Again, just like last time, we'll do the cross products. Y times y is y squared. And then 7 times 2 is going to give me 14. I'm ready to take the square root of both sides. And then now we can get y is equal to 3.74. That's your correct answer for y. Okay, one more problem, or one more thing to solve for this particular problem, and that's z. All right, so let's take a look at z and see which theorem we're going to use. Okay, so the question is z a hypotenuse, or excuse me, is z an altitude or is z a leg? All right, so z is a leg. So again, we're going to use the second theorem. So just like last time, we're ready for our blank proportion, and now let's start filling in the fractions. Remember, the geometric mean goes here and here. It goes in 2 spots. So the leg goes in 2 spots. What's the leg this time? It's z. Z here, z here. Now remember, the leg is the geometric mean between the entire hypotenuse. So the first number, once again, is the entire hypotenuse. How do I get it? I must add 2 plus 5 to get the full hypotenuse, which once again is 7. Now, here's where it differs from the last one. The second number is the piece of the hypotenuse connected to that leg. Well, what piece of the hypotenuse is connected to Z, 2 or 5? The one that's adjacent or connected to Z, that leg, would be 5. So this is how this one is different than the last one. When you're looking for Y, the one connected to it is 2. But when you're looking for Z, the one that's connected to it is 5. So that's how it differs. So now we've got our fractions filled in. We're ready for solving it. So Z squared, the cross product, Z times Z will be Z squared. And 7 times 5 is 35. I must take the square root of both sides. And then we will get Z is equal to 5.92. So square root of 35 is 5.92. And now we have all three of the answers that they've asked me for by using those two geometric mean theorems. Okay? Let's take a look at one more problem here. Okay, so here on this one, we're going to have to find x, y, and z again. So my x is here. Now, x is not the altitude, and it's also not one of the legs. It's neither one. However, if I were to solve this thing, right, try to solve it for x, let's see what parts would be involved. Well, I would have the x, and I need to look at the regular numbers. I don't want to have x's and y's and z's all in the same proportion. So if I'm trying to solve for x, the other two regular number pieces they've given me are 2 and 3. So if I have x, 2, and 3, what does that involve? In other words, what is 3? Is 3 an altitude or a leg? In other words, is the altitude involved in this setup or one of the legs involved in the setup? Since 3 is a part of it, 3 is an altitude, I'm going to use the theorem that involves the altitude, which is the first one. So this is the setup that I'm going to use. So if what you're looking for is not an altitude or a leg, look at the regular numbers that they've given you and see what's involved, whether it's an altitude or a leg. So again, I'm ready to write my blank proportion. And so when I do, remember, you want to put the geometric mean in first because it takes up 2 blanks of your proportion. Remember what this theorem says, the altitude is the geometric mean. So what's the altitude here? The altitude is 3, so that means 3 goes here and here. So 3 takes up 2 of the spots this time. Whatever the altitude is, that's what's going to take up your 2 geometric mean blanks. Okay, so now let's go ahead and see if we can finish it. The first, the numbers that go here and here are the 2 pieces of the hypotenuse. The 2 pieces of the hypotenuse now are 2 and x. So I'm going to put an x here. I'm going to put a 2 here. And let's go ahead and finish it. So now this will be 2 times x, 2x. 3 times 3 is 9. And I need to divide both sides by 2. And then so from here we can get x is equal to 4.5. That's your x. Now, notice one of the other things that they're asking me for is z. And so I don't even have to use one of these theorems to find z, because if from here to here is 4.5 and from here to here is 2, notice z is the whole hypotenuse, right? So all I got to do is do 4.5 times 2, and I've got that. That's 6.5. Let's go ahead and write the answer in there without doing a whole lot of work. Okay? Now you could set it up with the theorem if you wanted to. In this case, you don't have either one of the legs in terms of regular numbers, so this would be the best way to get it. Probably, I don't want to say the only way, but maybe the only way we know right now in geometry to get it. Okay? So I've got 2 of them. The only thing I need to find now is y, so let's set up a proportion for the y part of this. So now y is a leg, so I know that I'm using my second theorem, and so I know the leg is the geometric mean. So y will go in for GM here and here. And so y is the geometric mean between the entire hypotenuse, which is z, which we already know is 6.5. I'm going to put that there. And the piece of the hypotenuse connected to that leg. So which one is connected to the leg? 2 or x? 2 is the one that's connected to that leg, so I'll go ahead and write that out. Now we're ready for cross product. Y times y is y squared. And 6.5 times 2 is 13. And now we are ready to take the square root of both sides. And that's going to be y is equal to 3.61 is the correct answer there. All right, so there you go.